Our hands are important in the joy of complete fulfillment, suggesting that in relation to our senses, we lack a certain connection that is very important for living organisms. For instance, we see matter as primarily constituted of this dual nature, knowing that it consists of wave-like particles. Physics indicates that matter consists of something beyond just a corpuscular structure, allowing for frequencies that are part of the mystery of the unknown. Understanding that matter is also wave-like reveals the potential to create what these frequencies are, the sacred structuring elements of life. Taking this information, structural elements in cells like muscle, nerve, and hepatic cells, shows how they can transform from one type to another. Matter is constituted as both the corpuscle of life and information, emphasizing that it is this information allowing a living element to fulfill a scientific function. The key to life lies in this information, and in bioresonance we find ourselves within systems of information, working on the informational system or the wave system of matter. This magnificent framework describes wave behavior in a somewhat mathematical way. Focusing on the organization of living beings reveals that there are 100 trillion cells forming distinct systems, such as the respiratory system. This complexity indicates the importance of information, which is encoded within cells and dictates their functions and transformations. The essence of life is encoded in the information within cells, aligning with modern biological concepts where genetic information drives cellular behavior. Bioresonance highlights how living organisms interact with and communicate through their unique information systems. Wave behavior in relation to matter combines physics with biology, indicating a holistic understanding of how life functions. The dual nature of matter, as both corpuscular and wave-like, is rooted in quantum mechanics and is essential for grasping phenomena in both fields. The information contained within cells relates to DNA and genetic codes that provide instructions for cellular functions, allowing for complex systems to operate. Understanding these interactions informs how biological systems work at a fundamental level, driving the very essence of life. From the organization of cells into systems, like the respiratory and muscular systems, we observe the fundamental principles of anatomy and physiology. Each specialized function contributes to the organism's overall health and operation, revealing the intricate dance of life at a cellular level. Understanding how cells organize into systems fundamentally defines the study of anatomy and physiology. Each system plays a critical role, showcasing how the complex interactions between cells contribute to the overall vitality and functionality of living organisms. The interplay between cellular systems and external frequencies emphasizes the significance of bioresonance in health and biological processes. These systems reveal a mathematical framework that effectively describes how waves behave in relation to living matter. The study of wave behavior alongside biological systems provides insights into the fundamental principles governing life. This integration of physics and biology not only enriches our comprehension of living organisms, but also uncovers the mysteries that define existence. As we delve deeper into the connections between wave behavior and living organisms, the importance of understanding these interactions becomes clear. This knowledge opens new avenues for exploring how life functions through the intricate language of frequencies. Exploring the various frequencies that impact cellular functions reveals a deeper connection between life and the universe. This relationship illustrates how living organisms resonate with their environment, leading to a greater understanding of health and well-being. The use of technology to measure cellular responses to frequencies highlights the evolving field of bioresonance research. By looking at how these frequencies resonate through our environment, we can begin to appreciate the symbiotic relationships found in nature. Presenting research findings in bioresonance sheds light on how cellular frequency interactions can inform health practices and treatments. This interconnectedness serves as a reminder of the intricate web of life, where all living things communicate through shared informational pathways. Collaboration in laboratories highlights the collective efforts to understand the impact of wave frequencies on living organisms. Observing nature, we realize that even in a garden, life communicates through invisible signals, fostering connections among all forms of life. Understanding the communication between living organisms and their environments elevates our knowledge of biology to new heights. In educational settings, exploring concepts like quantum biology allows future generations to grasp the profound complexities of life on both a cellular and cosmic scale. The collaborative nature of research on university campuses fosters innovation in understanding bioresonance and cellular communication. By visualizing energy waves in ecosystems, We see how various life forms engage with and influence one another, reinforcing the idea that life is an interconnected web.